So we are going to find out the exact solution, okay? And this one is actually proposed by the Blasius. So we call it Blasius exact solution for Navier-Stokes equation or momentum equation. To solve this problem, we have these two equations ready. One is equation of continuity, and okay, this one we have. And another one, we have this Navier-Stokes equation. So we try to solve the x directional component first. So as I said, we already simplify it because it's steady state two-dimensional flow, and we have some assumption that the boundary layer is very thin, so the any parameter across it change abruptly, but the velocity is not changing in the y direction. Okay, so with those assumptions that I already explained, we have these two equations to solve. Okay, and you know that in order to get the boundary layer thickness is actually we are stretching the things, right? Y by delta, and we have u by u infinity, and if you plot it, it should be like this, okay? And this one is actually 1, and this one is also like 1. So this is actually same whenever or whatever position you consider. And you also need to remember that delta is a function of x, okay? So in this case, we can say that this is 1, okay? Okay, so here you can see this u by u infinity is actually a function of what? Y by delta, right? U by u infinity is a function of y by delta. So you can see there. And we also solve some problem where you see that u by delta is equal to maybe 3y by delta plus 4y by delta square, something like that, okay? And inside this one, we have y and we have the delta. But delta itself is a function of x, right? So what we can say that u by delta is actually a function of x and y. Although there is a delta, but delta itself a function of x, because the delta, that is the boundary layer thickness, changes with the x position, with the position, right? So this u by delta is a function of actually y and x, although we write it y by delta. So what we need to do here, we need to simplify it, okay? We cannot have this y by delta. We need to consider any particular variable that can represent both y and x, okay? Instead of considering y and x separately, we need to consider some variable that that can represent actually y and x together. Okay, some problem always. Okay, so let's consider the variable is eta. Okay, so let eta any type of variable that is y and also a function of x, that is gx. Okay, now let's consider a variable eta that can represent y and x together combinedly. So we can consider that eta is a y multiplied by x, gx. G is also a function of x. Okay, so what we need to know now, we need to evaluate these variables, okay, this derivative actually, du by dx, du by dy, del square u by del y, del square u by del y square. We need to find out this derivative term, and then we need to substitute it. Okay, so now we will do that. So let's try to find out du by dx, or we call it del u by del x. So del u by del x, using the chain rule, we can write in this way. du by d eta and del eta by del x. Simple, right? Just change rule. You can see that del eta cross down. So actually du by dl. So but is reusing the change rule. So you have d and del like this. So what will be du by d eta? What is du by d eta? So you know that u is equal to u infinity f from here. U is equal to u infinity multiplied by f. Okay, and f is a function of y delta is okay. Just we consider the f function. So what you can write here? So del u by del eta will be what? Del u by del eta, because this inside this is actually eta. Okay, so we actually considering this one is equivalent to eta. So f is a function of eta actually. So du by d eta will be, so if you write du by d eta, u infinity is constant, right? And that should be f prime. So in this case, f prime, what is f prime? F prime means df by d eta, because f is a function of eta, y by delta. Although we write like this, but it represents actually eta. So du by d eta is actually u infinity f prime. So I just write it here, u infinity f prime. Okay, multiplied by del eta by del x. So del eta by del x. So you know that the eta is equal to y g. This is y, sorry. From here, okay, eta is equal to y g. So if you have the eta is equal to y g, so your del eta by del x will be, y is a constant, right? Y cannot be function of x, so you just put it like y. But in this case, g is a function of x, right? So d eta by dx, in this case you will have g prime. So del eta by del x is nothing but y g prime. So here the g prime is what? G prime means dg by dx. Remember that f prime means df by d eta, g prime means dg by dx. G is a function of x, f is a function of eta. So you will have del u by del x is equal to this one, u infinity f prime y g prime. Clear, everyone? Okay, so if you note it down, already note it down, so I will continue. Next we are going to find out del u by del y. Similar way we can write using the chain rule, du by d eta multiplied by del eta by del y, and what you will get? Del u by del eta you already know before, u infinity f prime multiplied by del eta by del y, in this case only g, because your eta is equal to yg. So g is constant and del eta by del y means del y by del y is 1, right? So del u by del y is u infinity f prime g. Next is you need to find out del square u by del y square. So it means that you have to consider derivative of the above function, this one. You need to consider the derivative of this. Okay, so in this case, it means del by del y of u infinity f prime g. So in this case, u infinity is a constant, right? So just you put it like this, then multiplied by, I don't have space, so I just move here. Then we have two things here, f prime and g. Okay, so I can write in this way. Maybe I can write here u infinity, and then I can write df prime by del eta, then del eta by del y multiplied by g. Sorry, my multiplication become minus, it should be multiplied. So it means that if you have f prime, so I just make the chain rule here again, so it should be d, sorry, not del. So del eta will be cancelled out, so del f by f prime by del y, because I'm considering the derivative with respect to y. So in this case we have df prime by del eta, d eta, and then del eta by del y is same. It means that I am differentiating f prime with respect to y, but using the chain rule, and g is there already. So you have to consider uv function. So next is f prime will be there. Okay, so f prime will be there, and you need to consider the same rule, chain rule, dg by d eta multiplied by del eta by del y. Okay, so I am actually applying this one, f prime and g, these both are function of y, so I just make it fixed derivative with this one, and again make it fixed derivative of this. So now after you got this one, you know that the g is a function of x. There is no relation between eta, right? There is no relation of g and eta. So it means the derivative is actually 0. So this one is actually 0. So 0 means these terms will be vanished. So what you will have? So what you will have at last, you will have del square u by del y square is equal to u infinity, then you have d f prime by d eta, then if you see d eta by dy is means g, because eta is yg, so d eta by dy should be g, and there is another g, so g and g will become in this case g square. So now you already have the things that you need, del u by del y, del u by del x, del u by del y, del square u by del y square. Now you already have these things, right? So now let's try to find out what is the v from here, from this equation, how we can write the v. So v should be this mu del square u by del y square minus u del u by del x divided by del u by del y, right? So from this equation, Navier-Stokes equation, I just reshuffle it, and I want to write the u in this form. Sorry, v in this form. V should be mu del square u by del y square minus u, then you have del u by del x, and then you will have del u by del y. From where? This one we got from Navier-Stokes equation. Okay, so if you have this one, what you can do here, you just substitute the values. You can just substitute the values that you have calculated. Okay, so we have the mu, and del square u by del y square is which? What is the value? In u infinity, then you have del f prime by del naught, sorry, del eta, and g square. So you can write it mu, then you have u infinity, then you have the prime, right? Del f prime by del eta. F is a function of eta, so you have no objections, so you can write f double prime. Then we have g square, right? Then minus, then you have u. You know that u is equal to u infinity f, because you know that here u by u infinity is equal to f, so u should be u infinity multiplied by f. So you will have u infinity multiplied by f, and then you have del u by del x. Del u by del x is where we have calculated here, right? Del u by del x was u infinity f prime. Del u by del x was u infinity f prime, and then I forgot this one. This should be here, right? Del u infinity f prime y g prime. So I just write it down here. So this should be again u infinity f prime y g prime. This is u infinity, sorry. And then divided by del u by del y. It's like the same, u infinity f prime g. Okay, so if we simplify it, what you will get? I try to this by this minus this by this. Okay, then you have u infinity will be crossed down. You will have mu f double prime, okay, divided by f prime, and then we have g square, g cut down, we will have g minus u infinity will be cut down. There's another u infinity, right? One u infinity, two infinity. So one will be cut down, one will remain. So u infinity, and then we have f, we have y, and then we have g prime by g. Is it clear till now? So this should be v. Is it okay? Are you there? Which part?
I don't understand u infinity, number this one, u infinity minus f, and then u infinity f y g prime, correct?
Which one? Here or here?
Yes.
Here.
Yes.
Yeah, okay. This one is u infinity, because u is equal to u infinity multiplied by f. And then this one is del u by del x. Just put the value is u infinity here. Sorry, u infinity f prime y g prime. You can get this value from the top here. Del u by del x is u infinity f prime y g prime.
Okay.
Just put the values. So then you just simplify it, and then you will get the v. Because if I write here, my handwriting you see is very bad, because I cannot write properly in the digital board. It's not so good. Anyway, you just recognize what I said, then you will understand, not only just watching the text. Okay, so if you have managed till now, so what you are going to do? Okay, so you have v, but you know that we have the equation of continuity equation is del u by del x plus del v by del y is equal to 0, right? So what we are going to do, we already have v, but we need dv by dy. So we need to differentiate this one with respect to y again. Okay, so many differentiation, right? Okay, so we need to do del v by del y, differentiating with respect to y. Okay, so just one by one. Okay, here in this case your mu and g is constant. Mu and g is constant, and what else? So we again use the chain rule. So we will use d eta, then we have this part, right? F double prime F prime, then I don't have a space, multiplied by, sorry, del eta by del y. So I just make the derivative. So we need to consider d by dy. So instead of d by dy, I consider d by d eta by dy. Okay. So this is a function f prime, f double prime divided by f prime, because the this one and this one is constant. I make it outside. So same way goes here, but for the next term we have two things. Okay. First thing is we have this f and we have y. These two we need to consider. You need to use the what can I say, UV rule. So if I make it smaller, too small. So what can I say? So this one is multiplication. Okay. So next is minus. We have the minus here. So I just put here because not enough space. Minus. Then we use u infinity. Then we have g prime by g. Just I make it outside. And then I will have df by d eta, similar way. Okay, then we have del eta by del y, and we have y there, plus we have f, and then we have d del y by del y. Okay, you compare these two. So minus u infinity, okay, g prime by g is already there. Then you have f and y. So I just consider y constant here and derivative with respect to f. But f is a function of eta, right? So I use the chain rule, df by d eta by dy. You can see d eta cancel out, df by dy. So actually I'm considering the derivative with respect to y, should be okay. And next is we just consider f constant, f fixed, and then y derivative with respect to y. So dy by dy is actually 1. Okay, so this should be actually 1. We will have only y, and we have this y here. Okay, so just simplify it then. So what you will have should be equal to mu g, then we have d del eta, and we have f double prime by f prime, then we have d eta by dy is g, because y is equal to eta is equal to yg, so d eta by dy is actually g, then minus u infinity g prime by g, then we have df by d eta, and d eta by dy should be again g, and there is a y there, plus f. So these are eta. Okay, just put the values here, this one, d eta by dy is actually g. So again, just make it concise, but you will have mu g square d eta, we have f double prime by f prime, okay, and minus u infinity g prime, g will be cut down, and then we have f prime, because del f by del eta is f prime, okay, and then we have g prime, g cancel out, we have y, and then minus, so we have to multiply minus plus minus, then u infinity g prime by g multiplied by f. There is a f here, right? Okay, so this is the expression for del u by del y, right? Del u by del y. But we know that del u by del y, del u by del x plus del v by del y is equal to 0. So this one should be equal to minus del u by del x. It means that del v by del y is equal to minus del u by del x. So del v by del y means this expression is equal to minus del u by del x. Okay, so now what you need to do, you know already what is del u by del x. Del u by del x, if I am not mistaken, is minus u infinity f prime g prime y. So it means that this one is equal to this one, right? And you can see this part and this part will be cancelled out. If these two parts are cancelled out, so what we will have? We will have mu g square here, okay, mu g square. Then you have d by d eta f double prime by f prime, okay, is equal to, now you can see it's simplified, u infinity f g prime by g. Now you will have this u infinity f g prime by g. It's clear. Any questions? Any questions? Last part, okay. Yeah, okay. So this one we consider del square where I go, okay. Here we find out that del v by del y, right? So we have this expression, but from the equation of continuity we know that del v by del x, del u by del x plus del v by del y should be 0. So here del v by del y should be minus del u by del x, right? So minus del u by del x. But minus del u by del x is what? Del u by del x I already found out here. Del u by del x is u infinity f prime y g prime. So u infinity f prime y g prime is minus. So then I found that, okay, this term is also I have in the left hand side. So this part and this part will be cancelled out. So you will have only, which part you will have only? This part and this part. Right, I just shuffle it there. You can see mu g square del eta by del eta f double prime by f prime is equal to u infinity g prime by g f. Same thing I write. Is it okay? Okay. So after you got this one, so this one we can consider like this way. Okay, so now we have this, now we need to find out the, separate the eta and x part, okay. So what we do, d del eta f double prime by f prime divided by f. This f I just put it here, okay, go down, should be equal to u infinity by mu is constant actually, then we have g prime You have g and you have g square, so it will become g cube. So we have this integrating from right. You integrate. So this one is actually eta part, and this one is g part. G part means actually x part, because g is a function of x. Okay, so you can see this is equal to this. So let's consider this is equal to this is equal to k. This is, we consider it's just a constant, okay, because the ratios should be equal. So whether I consider k or p or whatever it is, that doesn't matter, okay. So this, as far as these ratios are equal, that's okay. Suppose that the equal is equal to k, some constant. So if you consider this k, so I consider the second part now. So what we can write now, I can write this one, u infinity by mu g prime by g cube is equal to k. Okay, so it means that I can write in this way, 1 over g cube, then dg by dx, okay, is equal to k mu u infinity, because it's g prime, right? G prime means g is a function of x, so I can write dg by dx. So this one can be written as g to the power minus 3, now is easy, dg is equal to k u mu by dv by dy per dv by dy. Hold on, I just finished it, this one. So mu by u infinity, and then we have dx. Just shuffle it, okay, and then you integrate, you will get what? So this will be g to the power minus 2, then minus 2 should be equal to k, and then you have mu u infinity dx, right? You don't have the dx, sorry. You will have x, sorry. You will have x and then integrating constant c. Integrating constant c. So at last you will have g minus g to the power minus 2. It means this one is equal to k. Yeah, this should be x, okay. But here I already put x. So 2 by infinity. This one is x, okay. This is x, and then c. This is integrating constant. Okay, so someone said something. You can speak, okay. Dv by dy, which one? Dv by dy part. Here, last blue color. Here, this one. Dv by dy. Previous. Oh, okay. This one. dv by dy. You mean the integration? This one. Okay. So. Okay. Okay. So dv by dy means you already have the v here. So you need to integrate with respect to y. So you have two terms. Okay. So in this case, your mu and g's, these are constant. Okay, so you have to integrate, differentiate with respect to y, and your function will be f double prime by f prime. So this is your function here, but you cannot differentiate with respect to y. So I use the chain rule. So this should be d eta multiplied by d eta by dy. Same, right? D eta cancel out. So it is actually d by dy. So just using the chain rule, I write d eta by this function and d eta by dy. That's all. And on the other hand, for this part, you have u infinity and g prime by g is constant. You have f and y. So you just consider f constant and then differentiate with respect to y, and again consider y constant and differentiate with respect to f. Okay. So here, what we do here in this case, we consider u infinity g prime by g and we consider y constant, fixed, constant means fixed, and then we differentiate with respect to f. So f is, we need to just write df by deta, deta by dy. And on the other hand, we consider f as a fixed, and then we differentiate with respect to y. So that should be 1. Then you just simplify it. Okay. So I just came back this one. Okay, so now you need to find out the c, integrating constant. How you can find out the c? You need a boundary condition, right? So you know that how can I say, eta is approximately equal to y by delta, right? Approximately equal to y by delta. So when the x is tends to 0 plus, very close to 0, your delta should be 0, right? At the initially there will be no boundary layer thickness, so delta also tends to 0. It means that eta tends to infinity. Something by 0 is infinity. Okay, it means just when x is 0, your eta is actually infinity. And you know that what is g? G is equal to eta by y, because eta is g y. So g is eta by y. So if eta becomes infinity, g will also become infinity. So the condition is when x is equal to 0 or tends to 0, your g tends to be infinity. Again, I'm saying the same. Okay, eta is equal to y by delta. If you have x0, your delta is 0. Something by 0 is infinity. Eta is infinity. And if your eta is infinity, your g will also infinity. So the condition is whenever your x is 0, your g is infinity. So if you put this g infinity here, one moment, I have a call. Okay.